Hello everyone. In this presentation, we will discuss about stereochemistry of diphenyl, or it is also known as biphenyl derivatives. So diphenyl or biphenyl compounds, as the name suggests, contain two benzene rings linked by carbon single bond carbon covalent bond. So here you can see that both benzene rings are linked via CC single bond. Earlier it was believed that diphenyl they have this kind of butterfly structure, and such kind of structure was proposed. But later on, one of its derivative 4,4-dinitrodiphenyl, which is shown over here, the top one, that compound was found non-polar, so magnetic moment 0, and also its crystal structure that shows the center of symmetry. Now non-polarity and center of symmetry, both these practical evidences, they are not proved by considering this kind of butterfly structure. So later on, it was accepted that diphenyl or biphenyl, they don't have this kind of butterfly structure, but they have this way, the shown in the bottom, coaxial structure, because here you can see that, see the two nitro groups, both having a magnetic moment equal but opposite. So it is non-polar as well as center of symmetry can also be explained. So now uh, diphenyls, it is proved that diphenyl they must have this kind of coaxial structure. Now diphenyl itself, uh, both the rings, they can rotate over a CC bond and they can lie in the same plane. Hence, itself is optically inactive. But some of the derivatives of the diphenyls can be prepared which are optically active. But they can be only optically active if they satisfy the following two conditions. So condition number one. Now you can see that both the rings, they have total 4 ortho positions, 2 each. So when at least 3 or 4 ortho positions of the both the rings, if they are displaced by considerable bulky groups like carboxylic acid group, nitro group, SO3H group, sulfonic acid, tertiary butyl group, etc., then these bulky groups, they produced steric hindrance, and that's why they prevent the free rotation about the carbon single bond carbon. In this condition, they prevent both the rings to be a coplanar, to be in a same plane. Here you can see that where my cursor is, that ring lie in the plane of this screen, while the another ring which we have shown with the this way, the darker line, right, this benzene ring is actually perpendicular to the plane of the screen. So now, because of the steric hindrance produced by these bulky groups in the ortho positions, they prevent both the benzene rings lie in the same plane. If the groups are smaller in the size, like a chloro or bromo or a hydroxy, then these groups cannot provide enough obstacle to each other and cannot restrict the free rotation of both the rings. And so both rings can be coplanar, and such derivatives are achiral and optically inactive. So first condition is we have to introduce 3 or 4 bulky groups in the ortho positions, and that way we can prevent both the benzene rings of diphenyl to be a coplanar. But that is alone is not enough. So condition 2 is this. Now you can see it first if you focus on the figure. Already both the rings, they are perpendicular. One plane is shown with the continuous line, another with the dotted lines. This dotted plane is perpendicular to the first one. But even after that, you can see that here both ortho positions of a same ring, they are displaced by the same group called methyl group. So when one of the plane bisecting the another one, then at equal distance, equal groups are found, and as a result, plane of symmetry is present. So, the second condition is that neither ring should have identical groups on both ortho positions, otherwise such derivatives contain plane of symmetry and cannot be optically active. And one more thing, even if you consider that particularly at this position and here, even if the same groups are there, but still there is no question of the center of the symmetry. Reason is that both the rings are perpendicular to each other. So even if we assume that at the place of nitro, suppose CH3 group is present, then the line starting from the CH3 passing through the center, and when you extrapolate it, then here you are not going to get the methyl group, as that ring is a perpendicular to the first one. So let me remind you, in the case of alene, both the pi bonds, they were actually perpendicular to each other. That's why there is no question of addition of such groups. In the spirene, spirocarbon was sp3 hybrid, and that's why, since it is a common carbon, but both the rings of the spirene, they lie perpendicular to each other. In the case of diphenyl, both the rings can be coplanar unless we prevent them by adding bulky groups. So, if we summarize, we can say that this kind of diphenyl derivatives either having all the four ortho groups different, like ABCD, they are chiral, they are optically active and resolvable from their mixture, or otherwise this kind of ABAB type of diphenyls, where already we have discussed that this ring is a perpendicular, so there is no question of the sigma v, or as shown here, alternatively, in A groups and B groups, they are in a relatively trans, but since one of the ring is a perpendicular, so there is no question of the center of the symmetry. And one more thing, I need your focus. Whenever you write the answer in the paper, you should draw one of the ring slightly smaller, and you should darken these lines. So we want to create impression that this ring is a perpendicular to the plane of the paper, and one of the ring is actually lie in the plane of the paper. So 6,6 dash. Okay, one more thing. Whenever we are doing nomenclature of the diphenyl, you can see that both these carbon are one first carbon, but in any one of the ring, to distinguish the carbons, we will use the numbers dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and here simply 1, 2, 3, 4, 5, 6. So naming pattern of this is 6,6 dash dinitro, 2,2 dash dimethyl diphenyl. Now it is chiral, optically active, and it is resolvable. This is its enantiomer. But as we discussed earlier, this ring cannot have both methyl or both nitro. Same for this ring, otherwise such derivative could be achiral and optically inactive. One more, 3 dash bromo. Here you can see the bromo. 3 dash bromo diphenyl. 2 trimethyl. In the place of carbon there is arsenic, arsenium iodide is resolvable. Now we can understand, if on the 3 dash carbon, if the bromo group is not in the form of displacement, then plane of symmetry could be present and such compound can be optically inactive. So I hope that you understand the stereochemistry of diphenyl in this presentation.